G'day. This video is about hands-on maths. It's one of a series. I'm hoping that you have a compass and straight edge and that you are able to download the worksheets from my website and do all the constructions I explain here. Today we're looking at the centre of a triangle. Now the centre of a triangle has four traditional centres: the Incenter, Circumcenter, the Orthocentre and the Centroid. As well, we'll have a look at the medial triangle, which uses the midpoints of a triangle. The first of our centres is the Incenter, and for each one I'll do a demonstration on the Geoboard. So the Incenter looks like this. A mathematical drawing of the Incenter looks like this. And then we can do the incircle, centered at the Incenter. Its construction looks like this. I do an arc from one of the vertices and then intersecting arcs. And with my straight edge, I bisect the angle. Now I go to another vertex and do the same thing. Strictly speaking, it's only necessary to bisect two angles. But since this is an exercise on using a compass and straight edge, we may as well do all three, and that will check the accuracy of your compass work. The second centre of a triangle is the circumcenter, the intersection of the perpendicular bisectors. On the Geoboard, it looks like this. A mathematical diagram looks like this. And now we can do the circumcircle, just touching each vertex. The construction is like this. In this construction, I've managed to get away with using just one radius on my compass. And if you watch, you'll see how I've done this. The orthocenter is the intersection of the altitudes. On the geoboard, it looks like this. A mathematical diagram looks like this. And the construction is like this. Now you'll have to vary the radius of your compass to make sure that on the first arc it intersects the side opposite the point from which you are dropping the altitude. And of course, that's a right angle. Same again for the other sides. An arc intersecting the side and two intersecting arcs will give us an altitude. The fourth centre of a triangle is the centroid, which is the intersection of the medians. On the geoboard, it looks like this. A mathematical diagram looks like this. This divides the triangle into 6 smaller triangles of equal area. Further, the medians are cut at a ratio of 2 to 1. Thirdly, the centroid is the centre of balance of a triangle. Now the construction will be to first find the midpoints of each side. So that's easily done. 2 arcs will do it. I don't need to draw a line. I just need to make a mark on the side to show that that is the midpoint, and I've added 2 hash marks to show that the side has been bisected. Now I draw lines from the midpoint to the opposite vertex in each case. The intersection of those medians is the centroid. And as I noted before, you have 6 triangles of equal area, and the medians are cut in the ratio 2:1. We can label the centroid, and we're done. Now I've added to this presentation the medial triangle, because it's also found using the midpoints. So on the geoboard, it looks like that. A mathematical diagram looks like that. Each line of the medial triangle, which subtends the same angle as a side, is parallel to it. And in an example on the geoboard, we can see in that case that it's true. Also, that line is half the length of the side of the larger triangle. And if we check our example on the geoboard, we find it is true in that case. So this means that the large triangle is similar to the medial triangle in a side-to-side ratio of 2:1, which of course means an area-to-area ratio of 4:1. If we check on the geoboard, we see we have a medial triangle of sides 3, √5 and 2√2. But there is another triangle of the same dimensions, and another, and another. In fact, we have 4 congruent triangles. Now the construction will start by finding the midpoints of each side. And I've found the 3 midpoints. And the medial triangle is simply joining those midpoints. It is a good idea to mark those sides which are parallel. Which are these three sets of sides. Each side of the medial triangle is half that of the side it is parallel to. It then becomes obvious that we have 4 congruent triangles, each of sides 1 hash mark, 2 hash marks and 3 hash marks respectively. And as I said before, the large triangle is similar to the medial triangle by a side-to-side ratio of 2:1 and an area-to-area ratio of 4:1. Now the Euler line. The great mathematician Leonhard Euler noted that 3 of these 4 centres fall on a straight line, and that there is a special ratio in the distance between them. In an acute triangle, it's not so obvious. And in a right triangle, we have some of the centres falling, for instance, the circumcenter falls on the hypotenuse in a right triangle, and the orthocenter is at the right angle. But in an obtuse triangle, both the circumcenter and the orthocenter fall outside the triangle. The centroid always falls within a triangle. But with those 3 points, we can then draw a line and make the Euler line. There should be a ratio of 2:1 between those 3 centres. And here's a mathematical drawing of the same. The construction, we have to find 3 centres. So I'm starting here with the circumcenter, and so this is going to take some time. Next is the orthocenter. In an obtuse triangle, I have to extend the lines in order to drop a perpendicular from point M. Extended a line and then drawn an arc through it, and then drawn intersecting arcs to get my first altitude. Point O, I'm going to have to do it again. Extend the line. Do an arc through that line and intersecting arcs. This is well outside the triangle, as you can see. And now I'm ready to draw the Euler line. From the Circumcenter, through the Centroid, to the Orthocentre. And now I can check with my compass whether I have the ratio correct. So here is 1. Now I'll do a line on the other side there. And I'll use the same radius. And there's a ratio of 2 to 1. I suggest you label your diagram the Circumcenter, the Orthocentre and the Centroid, and the Euler line. That's the end of this presentation. You can find more videos on YouTube, on my channel Math with Geoboards. And my website, I've already mentioned, has worksheets and other materials. I hope you enjoy learning in a hands-on way. I think it's the best way to learn, and it's why I make these videos. Hope to see you again in another video.